Hey folks, this tutorial is going to talk about our target number 4, which is the domain and range of functions. All right, we want to be able to identify what the domain and range of functions is. All right, so let's talk about what those two things are. All right, the domain of a function is the set of all possible input values. All right, so remember when we talk about input values in general, those are our x values in our functions. All right. And we would see those values on the x-axis if we were looking at a graph. Our range is our set of all possible output values, right? And recall our output values in general are our values y, right? When we're looking at a table or when we're looking at a graph, it'd be the y value of the graph, okay? All right, so let's talk about it. Here's one of our problems. So I want the domain and range of this function that's in a table over here, okay? And based on my definition, the domain is just the set of all possible input values, or all the input values. So in this case, it's just a short list of inputs. So my domain, I'm simply going to list those inputs, right? So my domain includes -4, -1, 0, 2, 4, and 6. Okay, you can list it simply like that. We have some different types of notation that we kind of like to use, but I'm just going to kind of keep it simple. I really want you to understand the concept. Okay, so those are my inputs. That's my domain. It's made up of those 6 values. All right, my range then is all of my outputs. So those are my y values. So here are my outputs. And in this case, it's just going to be a matter of listing what those values are. Okay, so I'm just going to list them in the order that I see them here. Okay, 7, 3, 1, 0. Now here's the deal. There's another 1 here. I already listed 1, so I don't need to list it again. If you happen to do that, it's not wrong necessarily, but I'm not going to list it again because I already have it once. I do need to list 5 though as well. Okay. So it turns out my range is just 5 values, and that's what they are. Okay, so that's if you have a table. All right, this problem, I want to find the domain and range from this graph. So my function is just graphed, and we're going to assume that my function, consists of just these 5 points as I see them. All right, so my domain again is all my x values. So what I need to do is I need to look at these points, and I'm going to need to gather the x value for each of those points, right? Because that's where my function shows up here. Okay, you can do this in a variety of ways. All right, you could go in and you could just write down the coordinate pairs for every point. So I'll maybe do that. So this point is -2, -2. So I'll write this down here. Okay. This point is -1, 0. This point is 2, 1. This point is 0, 3. Okay, 0, 3. And then this last point over here looks like that's 4, 5. Okay. Totally fine to list them out like this because now we can see where the x values are. All right, so my x values show up here, 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 and here. Okay, so I just need to list those out. My domain consists of -2, -1, 0 from here, 2, and 4. Those are the included or the possible inputs of this function. All right. I want the range. The range is the y values, right? So I'm going to just kind of highlight those here. I need all of these values to list my range. Okay, so -2, 0, 3, 1, 5. Nice to put them in order, not entirely necessary, so I'm not going to here. Again, nice if it is, doesn't have to be. Okay. Domain and range for this graph. Okay, so my definition is the same here, right? My domain is all the possible inputs or x values. Okay. My range is the set of all possible outputs or y values. Okay. So I'm going to go over here and I'm going to look at this. Well, my domain is all the possible x values. And if I think about this graph, right, this is a linear graph. This is a line. And these arrows indicate that this line continues forever. Okay, so if I think about where my x values are going to lie with this function, it's like I could choose any x value and it's going to be part of this function. It's going to be on the line because this really goes to infinity to the left or to the right, this direction, and this one goes to negative infinity, right? Because it's going that direction forever. Now we can maybe see the up and down, but we got to think left and right as well. So it goes to the left forever, to the right forever. So our domain, we can write this a few different ways. We call this all real numbers. Okay, all real numbers. Okay, there's a fancy R that you can write for that. That's a notation symbol that we use for all real numbers in math. That's totally cool. You can abbreviate ARN if you want to, but all real numbers just means we could pick any value, and it's going to be on our line somewhere. It's going to be included in this function. Okay. For similar reasoning, our range is also going to be all real numbers in this particular case. All right, and that is because, I'll do this too. That is because it's going to go up. In this case, it's going to go up infinity, up forever, and down infinity. It's going to go down forever. Okay, so these this domain and range are not restricted at all. Right? It's inclusive of every value that's out there. Okay. Next graph, domain and range, same thing. I want all the possible inputs x, all the possible outputs y for my range. All right, so my domain, again, I'm looking left and right. Right. Here's my x-axis. Now the arrows on this graph indicate, I can kind of see that, well, this graph is definitely going to go down forever. It's also going to continue going to the left forever. Now it's maybe going to straighten out a little bit if you think of it that way. It's not going to go too fast to the left, but it is going to go to the left forever to negative infinity. And for similar purposes, it's going to go to the right forever. Okay. So this domain also is all real numbers for this graph. Okay. However, the range is not all real numbers in this case. Okay. And here's why. Because if we look at our arrows on the graph, they're going down forever. So we're definitely going negative infinity, right, in both cases here. Okay. But there's a maximum value here that our graph never goes above. So, for example, we're never going to have a y value of 5 on this graph. It's not going to be included. So it's not part of the range, right? It looks like it's right here is the point that's kind of the highest. You can kind of think of it the highest point, right? And that is a value of 4. Okay, it has a y value of 4. Okay, so here's how we can list our range. Our range is y values that are less than or equal to 4. Okay, because it goes to negative infinity, and the highest it ever gets is 4. Okay, so we use this inequality notation often. If you're not too comfortable with inequalities, you can kind of just write it out in words, right? We want to understand that. We want to know that you understand the concept. Okay, so our range is all values equal to 4 and less than 4. Okay, one more of these graphs. All right, and you'll notice this one now. There are no arrows here. There are endpoints on this curve here. Okay, so our domain and our range are both restricted. Neither one of them are all real numbers because this graph doesn't continue in any direction forever. Okay, so my domain, and these are often the more complicated. I'm thinking left and right for my domain, my x value. All right, so what's the furthest left? I kind of think of these as walls, right? I could build walls, and if I built those walls, where would they be if I wanted to contain my graph? okay, I would build those walls right here, okay? And so my graph is between those two, all right? So my domain, and again, I'm going to use inequality notation, okay? It's between two walls, okay? The wall on the left is an x value of -1, and the wall on the right is an x value of 5, okay? So all of the x values between -1 and 5 are included on this graph somewhere, all right? Like here's -1/2, right? Here's +1.5, right? Everything between -1 and 5 are on here somewhere, okay? Now I'm going to do a similar thing with range, but I have to think up and down. So I think of range as well, I'll change my color here. Range, my y values, okay? And I think of that as a floor and a ceiling because I want to know up and down, okay? So if I put a ceiling on this that I wanted to keep my graph at, my ceiling would go right here. And then my floor, be careful, it's not here because my graph goes down this far. All right, so I would kind of make my floor here. Those are the highest and the lowest that this graph ever shows up. Okay, so that's going to contain my range. And so in this case, I'm going to do inequality notation again. My lowest point on my graph looks like it's at -9. And then my highest point on my graph looks like that is 7. So my range is all y values between -9 and 7. Okay. Again, if you're not comfortable with inequality notation, you can write this out in words. We want to know that you understand it. Okay. Right. I'm going to do one more problem here. So this is an application, and this is where domain and range starts to make some more sense in context. So this problem says the monthly cost of a new high-speed data service offered by SimData can be modeled by the function c of x. This is function notation, which we're working with a little bit. C of x equals 10x plus 45, where C represents the total cost for each user device x. Okay, so here are my variables being represented here in this function. So the domain, what does the domain refer to in this scenario? Well, remember our domain is all of our possible outputs, okay? Often our x values. In this case, it is our x value. Those are our inputs of the function, okay? But what does it mean in the context of this problem? Well, the inputs of this function are the user devices, okay? The user device x, okay? So the domain refers to user devices. Okay, actually number of, I want to be careful there. Number of user devices are domain of this function. The range then, okay, our outputs, in this case our output is in function notation, it's our cost, and I'm going to do green here, as a function of x. So our outputs, our range, are the cost, or the monthly cost, I could say, monthly cost. Okay. So depending on what my input is, my number of user devices, I would plug that in, and then my output would be the monthly cost. That would give me my range. Okay. Last question. Since this function is linear, and this is linear, it's mx plus b form, right? Slope, rate of change, y-intercept, starting value, sometimes we think of it. Since it's linear with both the domain and range, I don't like the grammar there, but it's saying, would it be all real numbers? Okay, now this is probably referring to, well, our lines look like this, right? And some of our examples, in fact, the one we did just a short time ago, the line went on forever, and it was all real numbers, right? Domain and range. Here's the thing, though. The domain, remember, of this function is number of user devices. Okay. So could we have 5 user devices? Sure. Could we have 38 user devices? Sure. Could we have 0 user devices? Sure. Could we have -3 user devices? No. that would not make sense in this scenario. So sometimes you have to think through some examples, and I encourage you to think about 0, think about negative, think about positive. So should this be all real numbers? No, it's actually not. All right, and my explanation, which you can write this down if you want, my explanation would be that negative values do not make sense. Okay, that would be one thing that we could say about this function and the reason why it would not be all real numbers. Okay, there you go, domain and range.